Hi everybody, let's look at 1.6, number 3. Here we have a Norman window is a window in the shape of a rectangle topped by a semicircle. A particular Norman window has a perimeter of 200 inches, and we want to find a function representing the area of the window in terms of the length of its base x. So just to make sure, we point out we have our rectangle. It has base x. I'm going to call these heights y. And we also have a semicircle. And you can notice that the diameter is x, or the radius is x over 2, right? So throughout this problem, we're going to be paying attention to using both of those shapes. What we want to start off by doing is, let's go ahead and find the perimeter in terms of the information that's given. So the perimeter is adding up all the sides. So that's going to be x plus 2y plus the circumference of the semicircle. And here I want to use the diameter, so the circumference will be x times pi. So I'm going to have my perimeter will equal x plus 2y plus pi x. I also see that I can factor out the x, and I know my perimeter is 200. So I'll have 200 equals pi plus 1 x plus 2y. So right here, I just factored out the x, and I used the commutative property to write the pi first. All right, this is the information we know for the perimeter. What we want to do is find the function for the area, and we want to do that so it's in terms of x. Let's hold off on it just being in terms of x for the moment and just focus on finding the area of both of these shapes. And so similarly to what we did here, we had our rectangle and we had our semicircle. For the area of the rectangle is x times y plus, and now the area of the semicircle is going to be half the pi r squared over 2. So we're looking at pi over 2 times the radius squared, which is x over 2 squared. This can clean up. We get area equals x times y plus x squared over 4, and then 2 times 4 is 8, so I'm getting pi x squared over 8. Alright, so this is where we can go back and look at the problem and say, oh shoot, that area has that y there. We want the area to be in terms of one input, just to be in terms of x. So what we can do is, if you go back to our perimeter, we can solve for y in terms of x, and then plug in the y that we get right here. So let's go ahead and solve for y. To solve for y, I'm going to start by subtracting pi plus 1x to both sides. And then I can divide both sides by 2. So 200 divided by 2 is 100, and then minus pi plus 1 x divided by 2. Now I'm going to plug in this expression into the y here. So we'll have a equals x times 100 minus pi plus 1 x over 2, right? So I just plugged in all this into the y there, and then plus pi x squared over 8. So this is a lot of like formula manipulation, but the goal is like you play with what you have. We know that the perimeter is 200. We had to state what this height was. Similarly, we use that information to find the area, and then we go back and look at the problem and see how they want us to express it. So all that's left to do is simplify our area function. Let's go ahead and distribute the x. And so we'll have minus pi plus 1 times x squared over 2 plus pi x squared over 8. All right, I have my x squareds, right? So it looks like if I make the denominators the same, I can combine these two terms a little bit more. So I'll need to multiply this fraction by 4 over 4 so that the denominator is 8. And I'm going to also redistribute my x squared and get this into a couple more terms. So we'll end up with a equals 100, 100x minus, and I'm also going to be distributing that negative, okay? So it's going to be minus 4 pi over 8 minus 4, oh, one second, minus 4 pi 8 x squared minus 4x squared over 8 plus pi x squared over 8. So what happened was I distributed the 4, I distributed the negative. I can now combine this one. Oh, that's not a good color. I can now combine this one and this one. So negative 4 pi over 8 x, negative 4 pi x squared over 8 plus pi x squared over 8 is going to be negative 3 pi x squared over 8. So we'll end up with a equals 100x minus 3 pi x squared over 8 minus 4x squared over 8. And what I can go ahead and do is factor out my x squared, factor out a negative 1, and just make this into a single term. And this is my answer. So you may be wondering, like, did I really have to combine all these like terms? Could I maybe have stopped right here and left it there? The thing is that when you get into calculus, you will want this to be in the most simplified form, so that when you go to manipulate it next, you don't have a lot of extra stuff then to play with and clean up. So you do want to try and simplify this as far as possible. Alright, so that was number 3. Keep up the great work, everybody, and I'll see you in another video.